I wanted to thank everybody for joining us here today. My name is Ben Snively. I'm a solutions architect out of the public sector group. So as a solutions architect, I work with customers to be able to help them architect solutions, build in compliance, security into those solutions, and really have that agility and innovation in AWS, but still build a system that complies to the security requirements that you have. You could kind of consider myself as an opening act. Really the primary act is with Casey and Stuart here. So they're going to come on stage after I give a quick introduction and really talk about some of the really innovative work that UPMCe is doing when it comes to healthcare. They're really doing some great work with a data liberation project and some other projects. How many folks in the room have workloads running in AWS already? Awesome. It's very, very cool. So a lot of this is going to talk about some of the aspects that you already know of, shared responsibility models, how do you build compliant workloads in AWS, and what it means to be compliant. So within AWS, we really have an infrastructure that you could build as a customer, a wide range of compliant workloads. We're going to really focus on what a PHI and a HIPAA compliant workload looks like and talk about what it means for an application to be HIPAA compliant. I'm not saying certified there, and we'll talk about why that is. But within AWS, you could really build a wide range of applications. So we have customers that are building PSI compliant workloads and things that require FedRAMP and FISMA, and in GovCloud, FISMA High and ITAR compliant workloads. So within the infrastructure is providing this really world-class secure set of services for you to build your application on. And we talk about agility and we talk about innovation as a lot of the reasons why customers go to AWS, but really security is another key reason why. So today, a lot of customers are actually going to AWS because of our infrastructure and the security posture of our infrastructure. And what it really means to build a secure application in AWS, it's good to understand what we do out of the box and what we provide as you as a customer as controls that you have. So, what we like to say in our shared security model is we actually have the responsibility of securing the cloud itself. So you don't have to worry about physical security and surveillance cameras and a whole bunch of aspects that really relate to the physical aspects of the services we're providing. But then as a customer, you have some options. So there's many ways you can encrypt data, right? We provide services like KMS, the key management service, for you to encrypt your data at rest. Or if you want to do things like use a HSM device, we have a cloud HSM service for you to encrypt your data. So what we really provide there is a set of services that gives you the flexibility to build the posture that makes sense for your solution. Of course, with IAM, you could set up various users, least privileged access, and really control your system the way it makes sense. So let's talk a little bit about HIPAA and PHI workloads. So AWS has been a platform that many of our customers have been using for PHI data for a long time. So things like genomics and PACS imaging and medical exchange systems. So many customers are building HIPAA compliant and PHI workloads on AWS. So back in 2013, Omnibus actually released a new ruling that really changed the way that business associates had to handle PHI data and what the requirements were for HIPAA. So what we did as a company is we actually looked at the different options and really found that a lot of the way BAAs were structured weren't really written in a way that fostered cloud. So within AWS, we don't have access to your data. We don't need access to your data. So part of that shared responsibility model really needed a BAA that was structured that was very, very catered towards that model. So what we did is we actually created our BAA. We started having customers signing that BAA back in Q2 of 2013 and have many, many customers that we have BAA agreements with to be able to handle PHI data. And all of that really boils down to, or really is built on that shared security model we were talking about. So in that business associates agreement, we talk about things that we'll do automatically and things that you have to do as a customer. For example, you want to turn on encryption at rest, you want to turn on encryption in transit. Those things, we have tools to make it very easy for you to do that, but that ends up fitting within your responsibility to turn those things on. And the way we handle really PHI and our BAA and the mapping of satisfying what HIPAA mandates is really mapping to the NIST standards. So what happens is NIST is the National Institute of Standards and Technology. And what that does is they actually produce various reports and various control matrices in order to make sure systems are secure. So the way we actually structure it is AWS aligns to the NIST 853 security control matrix. So within that matrix, just like physical security, we automatically handle certain aspects out of that control matrix. And then other aspects are handled by our customer, like user least privileged access for users. So within there, customers set up with an IAM, Identity and Access Management, that policy to satisfy that requirement under the NIST 800 standards. NIST also releases something called the NIST 866, and that's really where the mapping happens between the HIPAA security rules and the NIST controls within NIST 866. So that's how the mapping happens. We line to 853, that maps to 866, which then aligns to the HIPAA, the general statements of what needs to happen within the HIPAA PHI system. So we're constantly adding more and more services that fit under the HIPAA agreement. So within the BAA, we actually call out specific services within that agreement. One really important aspect is the way we structure the agreement is these are the services that are really meant for processing, analyzing, and storing PHI data. What that means is you can still use the other services. For example, there's actually an expectation people are using VPCs. People are using IAM. People are using other services, but it's not meant to be used to store the actual PHI data. So the BAA and these services are really focused on which services need to be used for the PHI data. The most recent additions are Aura and Postgres within the BAA. We also added the AWS Storage Gateway. I'm not sure why the image isn't showing up there, but you guys have seen all the super cool boxes with the drips falling in if you visited the Hall A over there. Also, with the load balancer, both the ELB and the application load balancer are actually supported within the BAA now. A year ago, it was the ELB only in TCP mode. So from there, I wanted to definitely welcome to the stage and Casey and Stuart for them to tell you a little bit about what the work they're doing. Thanks a lot. Grab the clicker.
All right, well, thanks everyone. I am very pleased to be standing here. And also, I know this is a bit of a rough time slot, so I appreciate that the room is as full as it is. So I'm very happy to be standing here on stage between all of you and tonight's festivities at the replay party. So I'll try to keep this brief and relevant. So I want to start by giving a bit of background on UPMCe, not because talking about my employer is the standard thing to do in a talk like this, but because it'll give you a bit of useful context and background for the size, the type, the complexity, and the sensitivity of the data that we're dealing with. So UPMCe is made up of three main pillars. This is its corporate headquarters in downtown Pittsburgh. It's the tallest building there. I think it's 62 stories. And conveniently, it is a triangle because we tend to think of UPMCe as being built on three pillars. Our provider network, which is all of the hospitals that provide care, our payer, which is our insurance program, and other stuff, which is where I work, and we're going to get into that later in the talk. So, click right? All right. So UPMCe it says 13 billion there. I was actually informed recently to do some recent activity. We're now a $15 billion integrated healthcare delivery net system, which means that the organization is made up of both a large provider network, which is comprised of 25 hospitals, 400 clinics, and thousands of employed clinical staff and docs, And then our insurance plan, which as of last month covers around 3 million lives. So it's rather large, and there is overlap in that Venn diagram between those two organizations, but our provider, all of our hospitals support multiple insurance plans, and our insurance plan also supports care in non-UPMC facilities. So in aggregate, that means that all of that together leads to about 6 million physical patient encounters per year, and all of the downstream data associated with that. It's a staggering volume. And we've also invested over $1.5 billion in technology over the past 5 years, which gets a little bit more into my neck of the woods. So UPMC Enterprises is the investment and technology creation division of UPMC. This slide has some of the partnerships, investments, and wholly owned businesses or products that we've created internally at UPMC Enterprises with our software development staff, some of whom are here, of 150 or so, and then we spun out into one of our portfolio companies. You can see that we're all over the map when it comes to the target for our products and businesses. We play everywhere in the healthcare ecosystem, from consumer-driven mental health and wellness tools to back-end revenue cycle operations to supply chain optimization to clinical decision support to home health down at the bottom there. Again, the point of this slide isn't to tell you about our business portfolio. I'm not here to sell you anything. But it should help to inform the diversity of use cases for the technology projects that are the focus of the remainder of this talk. Okay, so let's dive into the data. So this is a visualization of the clinical systems within UPMC that create data. At last count, there were over 1,000 of them, and the data is counted in petabytes per year these days. In fact, I would say in the past 2 years, I've been part of more and more conversations that are legitimately using the word petabyte in a legitimate manner, not just to make a rhetorical point. Perhaps most important and obvious as far as things to point out is the sheer number of them. When you're operating at the scale of UPMC, it's not your EMR or your EMRs, and in this context, I mean electronic medical record, not elastic MapReduce, which is an unfortunate acronym clash. But this is your IT reality, that long tail. And there's an incredible diversity in the behavior of those systems, of the type of data that they contain, the sensitivity of that data, the performance characteristics and access patterns for the systems. As far as sensitivity goes, just to drive the point home, if you think about what's hidden in there, or what's located in there, is everything from mental health status, HIV status, evidence of child abuse. This is the most sensitive data in the world, I would say, and it needs to be treated with great caution and respect. So another important observation is, unless you're an extremely diligent organization, just putting this stuff in a data lake, because of the diversity I just discussed, it opens you up to some systemic risk. If you have a handful of systems, or maybe even a few dozen, data lake can be relatively straightforward to implement and then manage with some of the core AWS technologies or with products from some of the partners on the expo floor. But when you get up to over 1,000, I posit it becomes nearly impossible to manage it with confidence. If you also have an equal diversity of use cases that are looking to execute on top of that collection of data. So I would also guess, so this was part of the motivation for our data liberation project that I'm about to talk about. And I would also guess that pattern is the exact motivation for the AWS Glue announcement that Werner made in this morning's keynote. And I must say that I'm very excited to learn more about that. So there are many ways that one could tease apart healthcare data. I've chosen 2 axes here to serve as the landscape for our analysis. First, we have on our horizontal axis, we have the nature of the data. On one side, we have discrete and structured information with a well-documented data model. And on the other end, we have unstructured narrative notes. A point of fact to note is at UPMC Enterprises, or at UPMC, empirically about 80% of the text-based data by volume is unstructured. And so next we have timeliness. At the bottom, we have semi-static or batch mode data systems, and at the top, we have real-time. And that is the realm of most electronic medical records. They do a very hard job, and most of it is comprised of real-time transactional type operations, placing orders, getting vital updates, dropping bills. As you'd expect, they also span the structured to unstructured spectrum. And when it comes to unstructured notes, while they often do manage and display them in a clinical setting, electronic medical records leave a lot of potential value on the table when it comes to what could be done with the information collected in those notes if you can unlock it. And this is the motivation for the second project, Neutrino, that my colleague Stuart Ingram will tell you about in a little bit. But back to the data liberation project. Back when I showed you that rainbow eye chart of data sources at UPMC, that was only the clinical data sources. There are also financial systems, HR systems, research systems, imaging and genomic sequencing devices, and hundreds of handcrafted research data sets, because UPMC at its core is also an academic medical center, and so we have academic research staff that hold dual appointments at UPMC and the University of Pittsburgh Medical School. So the DLP program, the Data Liberation Project, was designed to manage all of these types of data responsibly and securely. As I mentioned, data lakes and enterprise warehouses, they also play in this space. And we have nothing against them. In fact, UPMC has them too. And they're great tools for a broad range of use cases. So security and governance become more and more important, the more and more of a risk as the heterogeneity of your system grows. You have potentially sensitive data that a priori you know less and less about in aggregate. As for this graph, there are other characteristics I could have chosen. The data access pattern, is it transactional or analytical in nature? Do you commonly access one patient's info or a larger cohort? Then there's the diversity of users and environments. Are you a clinical user at point of care making a diagnostic decision, or a third party looking to address a business-driven hypothesis? So all of these lead to the fundamental requirements of the system that we actually created. The top line requirements are it needs to be very secure and provably compliant with all of the applicable regulations. We need full traceability of all data into and out of our system. And of course, it has to be built on infrastructure that supports the same underlying requirements. So this is where AWS has been a huge accelerator for our program. As most systems are that you actually care about, it must be resilient. So for us, we mean that in two distinct ways. First, it's the fundamentals of the system. It must be intrinsically available when you need it, but it should also be decoupled from our clinical operations at UPMC. We want it to be impossible for a workload that we're running within DLP to affect the performance or the availability of any of our clinical operational systems. We also want an uncorrelated failure scenario. Since most of our clinical systems at UPMC are on-prem, this also made AWS a natural choice for this project. And finally, as with all projects, it must be cost-effective. At UPMC Enterprises, we look at this on two axes. First is the standard operational running cost for the infrastructure and support. We're all familiar with AWS pricing, so enough said on that. On the second axis, though, is development cost. So we're a professional software development organization, shop at UPMC Enterprises, and we use agile methodologies to measure the velocity of our teams. We utilized the strong foundation of the baseline AWS services with tools like CloudFormation templates, combined with the baseline NIST templates to give us a known good starting point. Right, a known good starting point for creating and deploying our infrastructure in this way. So this allows us to manage our infrastructure as code, and I cannot say enough about that. If you're not using CloudFormation templates, look at them. It's, in my opinion, one of the best parts of AWS, because it allows you to, again, manage that infrastructure as code and then hence subject it to the same code review and deployment process that we've already developed over the years at UPMC for software. And so this served as a big accelerator for the delivery of the solution with quality and with reliability. So for those of you who are not familiar with CloudFormation or NIST templates, this is a diagram of what you get out of the box. We get this for free as a reference architecture. There are others, but this is the one that we found most applicable to our project. It's a general infrastructure that provides public and private subnet, a managed zone with a bastion box for focused private access, a known good network and security settings with provisions for integrated or separate dev and prod environments, and all of the minimum account and settings to make the functional infrastructure upon which to deploy your software. The key here is this is all expressed as a big decomposable JSON object or payload, which you can check into your source code management and treat as code. So what did we build? To be clear, this is not an analytics system, it's an asset management system. Mostly we wrote software that encoded and enforced our institution's data governance policies, as a superset to the federally mandated compliances. So in steady state, the surface area of this system is very small. We have to assume that we possess, as I mentioned, the most highly sensitive information in here in what we're calling the holding tank. We're utilizing an S3 object store fully encrypted as the non-volatile resting state for our vast quantity of data. This is where the petabytes live. And we keep it in the rawest form available on a per source basis. Our operational software knows about the S3 bucket, but it has no direct connection or rights to operate on it. Therefore, it's fundamentally impossible for our internal software to actually display PHI, which is protected health information for those of you who aren't familiar with trying to not bombard you with acronym soup. Tends to occur within healthcare. So for those of you not familiar with it, PHI is protected health information. What it does have direct access to is the metadata database that contains the information about the data assets, the governance and the decision-making process that led to it being in our holding tank in the first place. And for this, we utilized RDS MySQL, which again was on that slide as an included service that was available. And obviously, this whole thing is inside of VPC. And of course, as currently drawn, there's no mechanism to get data in and out of this diagram, so we need more. So here we add the mechanisms for data movement. While this is a relatively simple diagram, I do want to point out a few properties. First, all of the arrows are very deliberate in their directionality and their color. The red arrows, which are red on my screen, okay, good, and red up there, are crossing a security boundary. The inbound and outbound services themselves are actually ephemeral. They literally only exist when they're doing something, and we use a combination of CloudFormation templates, identity and access management, and Docker to provision a piece of software that, in the case of the inbound services, only has write access to the holding tank. You'll notice the arrow. So this service account that's created simply cannot look at what else is in there. It can only write. This tends to lead to some very desirable properties of the overall system. So the dynamic parts of the system are instantiated by the operational services software, which creates a cryptographically secure connection to our VPC for its operations. And for outbound, both the software and the data itself is considered ephemeral. We create a new S3 bucket in a different project-dedicated security scope. The outbound services software, which in this case only has read access to the holding tank, copies the appropriate data assets, and then creates the appropriate credentials and certificates for an end user for that, we call it a burner, S3 bucket only. So no human ever gets direct access to the holding tank. Before any of this software is even available to execute, the project, be it inbound or outbound, must provide the correct proof of approval and the artifacts to show that there's a full traceable path for that approval. It's part of our data governance. And that's largely what's kept in the asset metadata part of our system. Information about the asset and the full history of how it ended up in our holding tank. So once an outbound project possesses that approved state, the tools become active to our administrators to instantiate the data movement software. So the use cases that we cover are potentially very broad. I'd say the biggest customer of this is UPMCe Enterprises itself. As you saw earlier, we have a broad portfolio of investments and companies. In the pursuit of adding to that portfolio, we want to make informed choices. And many of those often involve de-risking certain claims from potential partners. So if a group says, if we only had a year worth of electronic medical record data to churn on, we could train this machine learning algorithm to do X. This type of project doesn't need real-time access to our clinical systems, and to a first approximation, it can probably train on last year's data, at least to prove the point. So now we can test that claim without having to worry about the operational impact of that project to what we actually do for our day jobs at UPMCe, if you're not part of UPMCe Enterprises. So UPMCe Enterprises also manages the Pittsburgh Health Data Alliance. It's a partnership between UPMCe, Pitt, and Carnegie Mellon, or CMU, to do early stage data-driven research on genomics, bioinformatics, applications of machine learning, with the hopes that some of them, beyond being good science, could lead to ideas and solutions that UPMCe Enterprises could then take and commercialize and offer to the market. So at any given time, we have dozens of research projects going. In fact, I reviewed 3 of them on the plane flying here. And they all need data, which needs to be provided in a responsible, repeatable, and traceable way. So now we're going to switch gears and talk about another software project that we created internally at UPMCe Enterprises and implemented on AWS recently, with the goal to unlock that vast potential value hidden inside unstructured notes. And for that, I'd like to introduce my colleague, Stuart Ingram. Thank you.
That's advanced. Perfect one. Thank you, guys. It's a pleasure to be here. Oh, there we go. Clinical documentation. So 80% of your medical record today is thought to be trapped in unstructured clinical documentation. And why do I say trapped? Well, this is in the EMR. but it's not discretely available in the EMR, and that means it's not actionable. Every single line in this document, this example that you see behind us, has value, right? Everything in there conveys some piece of information that could be actionable in some way. And like my colleague Casey said, there's also a lot of abbreviations and clinical context in here, as you would imagine. It's a clinical document. But that adds challenges in itself. What do these acronyms mean? IV. Does that mean intravenous, or is that the fourth lumbar vertebrae? You need some context, you need some smarts. At UPMCe, we have over 5,000 variants of documents like this from the multitude of systems that my colleague described earlier. They come in text form, RTF, PDF, Word documents, images inside PDFs, all kinds of stuff. They can be entered directly by clinicians, or they can be transcribed through automated services or manual services. But this is where the data is. There's two challenges here. One, tapping into the data. Number two, aggregating the data. So I want to spend a little bit of time talking about the potential of having this all aggregated and a deep understanding of what's in the clinical narrative. So let's start with patient-centric. Very, very simple. You can't make good clinical decisions if you don't have all of your medical information at hand. You don't know what's relevant. So having this all in one place, it's sensible, right? I've got more information, I should be able to make smarter decisions. But there's a flip side to that. Now that I've got way more information, how does the physician actually get to it? There's a signal-to-noise problem. And that's where the deep understanding of the documents comes from. Rather than just relying on chronology, source of information, type of information, I can now navigate by deep learnings within the document. What are the problems? What are the allergies? What is the medication? I can now look at the document in the context that I want to. Now, this particular use case is very sensitive. It's not very error tolerant. Excuse me. You want to look at a patient's records and nobody else's records. If we step up to institutional compliance, with a deep understanding of the complete patient record, I can now provide actionable coding activities. Have I documented chronic disease states correctly? Are my documents documented correctly? If I mentioned lithium, did I mention bipolar? If the patient is on insulin, have we documented diabetes? If we step up even further, we can now do patient analytics. The way the data is spread around and the shallow understanding that we have of it, it's very, very hard to identify very tactical populations. If I wanted to know all of the males in the Pittsburgh region over 50 with diabetes that had a heart attack within the last year, it's kind of tricky. But if we've got it all in the same place and we have a deep understanding of the information in there, that suddenly becomes a little easier. If we want to do analytics and start to go down the path of precision medicine, having all the information in one system with a deep understanding enables these things. So we talked about clinical documentation and just the use cases of gathering that together. And there's a lot of potential there. But if we look further abroad, your medical record contains more than that. You have images, radiology, pathology, dermatology, and other image types. Genomics is becoming an incredibly powerful force in healthcare today. Huge amounts of data and insights about what you have a proclivity to, what you have resistances to, those kind of things. You as consumers are also generating important information about your health through wearables. How often do you go for a walk? How often do you run? How often do you swim? Do you sleep okay? What's your BMI? Your scales are now wired up and essentially convey important healthcare information about your record. All of this data falls into all of these use cases, providing more actionable information to improve outcomes in your health. So let's talk about the challenges. Let's imagine that now that we've set the objective and we've talked about the goal, what are the challenges with building a system that would enable this, right? Well, we talked about variety. Variety is an obvious one. We have a plethora of sources, and they may all behave slightly differently, have slightly different tolerances. Workflows may be different in terms of who signs off on what when, what is considered the date of service. The content may be different. So if we take a history and physical, which is a fairly common clinical document, how it's represented within one system is consistent, but may not be across all of the systems. So it's very difficult to template these out if you're talking about hundreds or thousands of systems. The format we've covered, that's a fairly straightforward technical one. Veracity is probably one of the biggest challenges. As I said, if you want to build a system for clinical point of care, and you have a multitude of systems sending you information, and all of those systems understand you through a different identifier, it becomes a very challenging job to make sure that each record is associated with the correct individual, the logical patient from all of these physical systems. And it's incredibly important to do so. Volume and velocity, they're not necessarily specific to healthcare. They're more scaling issues. At UPMCe, we have 3 million plan subscribers, and we have 6 million patient events per year, each one generating many, many nuggets of information, many, many clinical documents and other data points. Velocity, we have over 700,000 documents created per week. It peaks at about 300. These are fairly straightforward. They're not necessarily complex. Every one of you has scaling opportunities and challenges in front of you. There's another V here, versioning. So we want to become a repository of truth, right? In the clinical workflow, we have preliminary versions, we have final versions, and we have addendums. Now, depending on the system, the addendum may be a complete record, right? It may be the record with the change, or it may just be the delta. Also, as a repository, we want to delete nothing. If a physician made a decision based upon a record, and that record turned out to be incorrect, we don't want to delete it. We still want it there for traceability. As Casey mentioned, there are other nuances. While it's PHI and all of your data is confidential, some data is more confidential than others and requires additional safeguards to access. Also, mistakes happen. When staff generate clinical documentation, they may misassociate it with an incorrect patient. A system like this needs to handle the navigation of one document from an incorrect patient to a correct patient with record that that system had a mistake in it in case mistakes were made. So a lot of things to consider here. And that's why we built Neutrino. So Neutrino has, as you would imagine, two key tenets. One is the centralized repository of truth for the organization. We want real-time ingestion. We want to absorb all of this information from all of the component systems and make it available with the shortest possible latency. Document normalization. As I said, every system represents their documents slightly different. How they describe a history and physical in one system may be different to another. But you as a user of a centralized repository, you don't want to worry about that. So there's a normalization effort that needs to happen as well. Document verification, incredibly important again. We absolutely need to make guarantees that the information that we are associating with the patient record is correct. Patient crosswalk, that describes the graph of identities that you as individuals are recognized as throughout the multitudes of systems, so that when somebody uses Neutrino and they say, I would like the information for this particular MRN or identifier, we walk the crosswalk, we gather all of the physical identities that you are known as throughout all the documents so that they can be harvested as one logical block. Again, we're a repository of truth, so we don't want to change any of the source information that we received downstream. And of course, the obvious ones, right? It needs to be durable. Can't lose any information. It needs to be scalable. It needs to be able to grow. UPMCe is an ever-growing organization. The data is only going to increase. And increase both in terms of the number of patients that we service, but also the kinds of documentation that we want to gather. And of course, if we're building a point-of-care system for clinical decision-making, it absolutely has to be reliable. So the second part, so that deals with the aggregation of all of the data in one place. We also use, we want to crack it open. We want to make all of those insights discoverable and actionable. And to do that, we use natural language processing services, right? It's an arm of computer science that understands the written language. And in this case, we're looking for a very, very specific kind of NLP service that understands clinical language. As you saw before, it's not war and peace. It's something very, very specific to the domain. And we need an engine that can handle the challenges associated with that domain. And because it's challenging, there's no one NLP engine out there that does everything perfectly, okay? One NLP engine may be great at discovering problems. Another one may be awesome at looking at medications. And with that end, we support multiple NLP engines. So I just wanted to go over the architecture real quick for Neutrino. This is a fairly grossly simplified representation of it, but it should convey roughly how it works. So in the gray, we have our external systems as suppliers of data, if you will. We have in green the edge of Neutrino. We have blue the API and the workers. And down at the bottom, we have Mongo and S3 as storage layers. And we'll come to those later. So very simply, we have document sources. You can think of these as EHRs. And they supply data through a protocol called HL7. HL7 is the protocol for exchanging information in healthcare. It's a TCP/IP point-to-point protocol. Not very good for scaling, right? So we use an open source technology called Mirth Connect to do the translation between HL7 and convert it into a HTTP RESTful JSON payload, which allows us to scale and use modern architecture. Okay? From there, we use the API and we store it in Mongo. And this is a synchronous operation, right? We want to respond back to the server. Hey, we've got this piece of information. We've stored it securely. Move on. Don't worry about it. From there, we have an internal message broker system and a number of asynchronous workers that move the documentation down the pipeline. So retrieval of any remote content if that's necessary, validation of the documentation to make sure that it's associated to the correct individual. We have NLP. And then right at the end, we want to aggregate all of the pieces of actionable information that people are interested in and index them so that they're discoverable. Okay? So there's another component to this system called the patient identity. Patient identity, again, follows a similar pattern. We listen to ADT messages, which are admit, discharge, and transfer. It's a special form of HL7 message. And that goes through Mirth, converts it to a JSON payload. And we actually store that in our own hosted MySQL. We don't use RDS here because we want to use a memcached plugin from MySQL. And what that allows us to do is to treat MySQL like a key value store. It goes straight through to the B+ storage engine in MySQL and gives us full ACID compliance. So we actually moved from Redis to MySQL very, very easily using this methodology, but unfortunately RDS doesn't support this right now, so we're hosting it ourselves. But it's been very successful for us. Okay, so I want to spend a little bit of time talking about data access and characteristics. For some of you, this may be obvious, but this is kind of an important tenet and kind of talks to why we're using the technology that we're using. So a document asset on its own is useless. We get a binary PDF, okay? I can't do anything with it. It has to come with metadata. We need to understand where it came from, why was it sent, and more importantly, which patient is it associated with. Those two are an intractable tuple. They cannot be separated, okay? So the document asset, we find, for all of the workflows that we've looked at, is a very individual kind of action. We don't want to bring up 20 documents all at the same time. I'd be impressed if all of you could read 20 documents simultaneously, right? You're very much, I want to read this document, I want to read the next document, and so on and so forth. So for that, a key value store makes a lot of sense. That's why we use S3. The metadata, we want to search across, right? We want to find out all of the records that belong to you as an individual. And that's not necessarily as easy as select star from user where patient equals 123. It's actually a collection of identities. So something like Mongo makes a lot of sense for us. When you think about NLP, NLP takes the document and it gives us a list of insights, a list of annotations. And every service is different. So what we want to do there is save that off as a frame of reference. Again, we're a repository. We don't want to lose anything. People make decisions on this. We need traceability. So we save that off to S3. And then at the end of the day, we're extracting the information from the NLP-derived annotations, from the document and from the metadata, and putting that in an index that's searchable and actionable. Now I want to step back a little. So this is pretty straightforward. We get a document, we run it through an NLP service, we gain some insights that we didn't have before, we store the document, we store the insights, and we have a pretty good system there. But earlier I talked about other forms of information. So if we take a step back and think about just assets, right? For instance, let's talk about images. Let's say we've got an image. An image on its own is still useless. It still needs metadata. We still need to understand where it came from, why it was taken, and who it's for. If we replace NLP with an annotator, think an imaging algorithm. What's the percentage, what's your chance if this is a slide of your thyroid? Maybe there's an algorithm out there that will tell you your percentage risk from it being cancerous. It's an annotator, right? We still want to take the original information, the metadata, and any deep insights learned through a secondary service and make them indexable. So this patent holds for all medical data. Excuse me. So as Casey said, we take privacy very, very seriously. A lot's been already said about it. But if we look at the basics, what does HIPAA mean? It means protecting your data. It means all information, all PHI in flight needs to be encrypted, which Neutrino does. All information at rest also needs to be encrypted and protected. S3 provides that through a multitude of ways. All EBSs can be encrypted through a multitude of ways. Amazon provides very, very strong protections for PHI data. We also need to log all access to PHI, right? So we ship our logs to S3, and we put protections so that they can't be tampered. We cannot delete, we cannot update our logs, and only certain people have access to them. Our security model is much like you would imagine for any other database. We don't necessarily authenticate individuals, we authenticate applications as service accounts. And we delegate the responsibility for authenticating and authorizing individuals back to the client applications. So why did we choose S3? The uptime is fantastic, 4 nines. We need that for clinical point of care, not so much for research, not so much for coding. But if a practitioner, if a physician is making a decision, the information needs to be available. Very importantly as well is durability. 11 nines is kind of insane. I highly recommend you look at the description on the S3 website. It's something crazy like storing a gig for 100,000 years, and then you may have a chance about losing some data. Okay? It's secure by default, which is a very, very strong and beneficial position for us. It's secured through IAM roles, ACLs. I already mentioned, the fine-grained control that we have over logs. TLS on the wire, again, satisfies HIPAA. Server-side encryption. You can just roll out the defaults. You can use KMS. You can use something a little fancier that you have custom. VPC endpoints were added recently, which basically routes traffic directly from your VPC to the S3 service. And again, adds another layer of security. Your information is basically taking the shortest path between your application and the S3 service. You also have an access log. So we already have our own access logs, but S3 provides its own access log that gets stored via CloudTrail. Again, Very, very desirable properties for anything working with PHI. Finally, the cost. The cost is very advantageous. And for Neutrino, we've cut our running costs by about 30%. So I just wanted to touch on some stuff that my colleague already touched on, CloudFormation. So as Casey mentioned, we're investors, but we're also innovators and incubators. And as such, we don't want to reinvent the same wheel multiple times. We want to maintain high velocity and focus in on product. CloudFormation allows us to do that. We want to be able to spin up and spin down architectures and know that they have the same secure properties to look after your PHI. And as Casey said, AWS provides a very, very secure networking-based template out of the gate that supports NIST 853. You've got bastions, you've got multiple availability zones, you've got guidelines for public and private subnets, as well as NATs between them. It provides a very, very secure baseline for all of our projects. But let's go beyond that. Okay, that's nice out of the box. But we want to use Mongo, so we've put together a cloud template, CloudFormation template for that. We're big believers in Kubernetes, so we have a cloud template for that. We want to use Elasticsearch, but that's unfortunately not HIPAA compliant right now. So we put together a cloud template for that. And what that means is all of the teams that want to use these technologies can just pluck them right out of Service Catalog. It's a huge accelerator for us. And as Casey mentioned, infrastructure as code absolutely is the way to go, right? It's repeatable, it's fast, it's automated. And more importantly, I think, it goes through the rigor that you can put your own code through, right? It can be evaluated statically, it can be peer reviewed. These things are incredibly important to us. Finally, I just really wanted to touch base on CloudTrail from the point of view of PHI. Compliance, but also as well for organizational comfort, right? Your enterprise comfort. Every single command that you make and interact with in AWS gets stored in CloudTrail. This goes a long way towards making people comfortable with PHI in the cloud. It really does. So in summary, I just wanted to cover the two use cases. So we have the data liberation project, okay? High volume data, low velocity, it's batch. And we have Neutrino, which is a very different, real-time, high velocity, high volume data. Both of these platforms have in common security, high levels of compliance for HIPAA and organizational compliance. They have to be reliable, and most importantly, they have to be durable. If we are stewards of your information, we absolutely cannot lose it or corrupt it in any way, shape, or form. And that's why we trust AWS services. And finally, the cost profile is very, very advantageous. So in summary, I'd just like to close. Enterprise volume PHI is in the cloud. It's here. The cloud is ready. And UPMCe is doing that today at enterprise workloads. So with that, I'd like to thank you all for your time and your attention. It's greatly appreciated. Remember to fill out the evaluations. And if you have any questions for me or Casey or Ben, we'd be happy to take them. Thank you.